This is the final lab, modeling planetary motion. The objective of this lab is to use planetary data to model the motion of the planets and to relate Newton's laws of motions to Kepler's law of planetary motion. This is the solar system. The planets orbit the Sun due to the massive gravitational force exerted on the planets by the Sun. To model the motion of the planets, we need this table of data. This will also help us relate Newton's laws to Kepler's laws. Kepler's three laws. The first law, the law of ellipses, states that the orbit of each planet is an ellipse with the Sun at one of the two foci. The law of equal areas states a line joining a planet and the Sun sweeps out equal areas during equal intervals of time. And last, the law of harmonies states that the ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distances from the Sun, or t squared over r cubed should be the same for all the planets in the solar system. While Kepler's laws describe the motion of the planets in our solar system, Newton's second law and Newton's law of gravity drive the motion of the planets. F net is equal to F grav, and F net causes the change in momentum of the planets. F net is comprised of F net perpendicular and F net parallel. These components create the components of the change in momentum. The perpendicular change in momentum describes the planet's angular momentum around the Sun, or the red line. The parallel change in momentum is the speed at which the planet moves in orbit, or the blue line. Here we have a computational model of the planets driven by the gravitational force described by Newton's laws. The force of gravity changes the velocity of the planets at each time step, in this case a day. The velocity of the planets causes a change in the planet's position. Because the planets are moving with an initial velocity, they do not fall towards the Sun. The key to relating Newton's laws of motion to Kepler's law of motion is the law of harmonies. The law of harmonies states that the period squared divided by the radius cubed should be the same for all planets. Newton used some basic reasoning and the assumption that the planets have a mostly circular orbit to relate Newton's laws and Kepler's laws. As you can see here, the data of the period and the average distance of the planets from the Sun are all roughly about 1. And so, Kepler's law works with Newton's laws.